Hey, it's Joshua, room 6. We've been copying the whole library. Now we cut it up. Replication put a full copy in every branch. But what if the collection is too big to fit in any single building, even the leaders? 1 billion books. No one shelf holds them all.
Our head librarian has a new problem, and copies cannot solve it. The collection has grown to 1 billion books. No single building can hold it, and every new book still has to pass through her one desk, one pair of hands, 1 billion edits. So she stops trying to hold everything in one place. She takes the collection and she cuts it into pieces. Authors A to F, this building, G to M, that one, N to Z, a third. No building holds the whole library. Each holds a slice. Careful here, because we have met the word before. In the storm, a partition was the network splitting on us against our will. This is the opposite. This time, we do the splitting on purpose to make the data fit and to spread the work. The library's word is sharding. The cloud's word is partitioning, the same cut. Now a reader wants one specific book. How do they find it among 1 billion across 12 buildings? With the rule, the cut itself is the map. The author starts with C, that is the A to F building. You go straight there. And that is the magic. You never search the whole library. You search one slice. 12 buildings, each 1/12 of the size, each fast. The rule that cuts the data is the same rule that finds it. But the cut can betray you in 2 ways. The first, what if everyone wants the same author? One celebrity memoir, and the A to F building is mobbed, its doors jammed, while the others sit empty. You split the books evenly, but not the attention. That is a hot shard. One slice on fire while the rest sit idle. An even cut of the data is not an even cut of the load. The second betrayal. Someone asks, list every book published in 1990. That answer is scattered across every single building. Now you must ask all of them and stitch the pieces back together. A question that crosses the cut lines is slow and painful. So here is the idea, plainly. Sharding, or partitioning, means splitting your data into pieces and putting each piece on its own machine. The whole becomes bigger than any one machine could ever hold. And the right split too, because each piece has its own desk, its own leader. The rule that decides which piece holds what has a name. The shard key, or the partition key. Choose it well, and every machine carries a fair share. Choose it badly, and one machine carries everyone. The key is the whole game. It decides whether your load is even and whether your everyday questions stay inside one piece or scatter across them all. Here's the keeper. The principle is yours. When the data is too big or too busy for one machine, you cut it into independent pieces by a key. That buys you scale with no ceiling. And the toll is the key itself. The cut must spread the load evenly and keep your common questions inside a single piece. A bad key gives you a hotspot or a question that has to visit them all. The labels are the stickers. DynamoDB calls it the partition key and warns you about the hot partition. Engineers say shard key, high cardinality, even access, the same lesson. And here is the deep trade-off, hidden in how you cut. Cut by range, A to F, G to M. And ranges are easy. Every author from C to E lives side by side. But popular ranges run hot, and a flood of new authors can pile into one building. Cut by hash instead. Scramble each key into a random-looking number, and the load spreads beautifully, evenly, no hotspots. But you have thrown away order. Authors C to E are now scattered everywhere, and a range scan has to visit them all. Even load, or easy ranges. You usually cannot have both. So the exam asks it as symptoms. One DynamoDB partition is throttling, while the table sits mostly idle. That is a hot partition. Your key has low cardinality, or skewed access. Pick a key with more distinct values and more even traffic. Writes have outgrown what one database can take? You shard, splitting the writes across pieces by a key. And if it is a relational database that does not shard easily, that very constraint is often why teams reach for something like DynamoDB, which partitions for you from day one.
Your turn. Out loud or in your head. I'll wait. A social app. Billions of posts, and you have to shard them. 2 candidate keys are on the table. The user's ID or the date the post was made. Which key do you cut by, and what exactly goes wrong if you pick the other one?
Cut by user ID. It has millions of distinct values, so the load spreads evenly, and show me one user's posts stays inside a single piece, fast and fair. Cut by date, and today becomes a hot shard. Every new post hammering one machine while last year's sit idle. And one user's posts now scatters across every date. The wrong key turns one fast question into 1,000 slow ones. So that is sharding. Cut the data into pieces by a key, each piece on its own machine, and let the rule that cuts it be the rule that finds it. The whole game is the key. And look back down the hall. The storm forced the choice. The dial sized it. Taste spent it. The cache kept a copy close. The branches spread copies wide. And now the pieces let the data outgrow any single machine. That is the shape of how data scales. One breath to seal it. Sharding splits your data into pieces by a key, each piece on its own machine. The whole outgrows any single one. The shard key is everything. It must spread the load evenly and keep your common questions inside one piece. A bad key gives you a hot shard or a question that visits them all. Choose the cut, and you choose how far you can grow.
That is sharding, and that is the data wing of the map. 6 rooms down. I'm Joshua. I'll see you in the next one.